Welcome to MOOC on Statistical Methods for Psychological Research 2. Today, the module on hypothesis testing for differences among 3 or more groups is the topic for discussion. We are all aware that hypothesis testing is one of the most crucial and vital in decision making. In a part 1, I am going to cover testing of parametric and non-parametric hypothesis, a general information. So, while listening this module, you are going to get the contents on the notion of statistical hypothesis, more specific to parametric and non-parametric related to null and alternative hypothesis, with an objective of these tests related to more than 2 things under comparison or testing. So, by the time of this completion of the module, we are going to discuss about how to test the significance of difference between more than 2 groups, parametric and non-parametric. Test the significance, we are going to make use of ANOVA for parametric tests and Kruskal-Wallis test for non-parametric. So, the contents at a glance, we are saying that I am going to discuss with you people is that sample and population, estimator and parameter, parametric tests with more than 2 parameters, non-parametric tests for more than 2 groups. So, what analysis of variance? The purpose is to verify the significance of difference between more than 2 means 3 or more, means if you want to verify, we need analysis of variance. It comes under the category of parametric testing of hypothesis. Of course, we are going to explain the concept of post hoc parametric tests more specific to ANOVA. So, non-parametric test for more than 2 groups, which is we are making use of Kruskal-Wallis test, that is alternative test for ANOVA. ANOVA one way is meant for parametric testing, Kruskal-Wallis test is meant for non-parametric testing. So, testing the parametric and non-parametric, basically we can say that if there is only one variable, whereas more than 2 categories, for parametric test we may make use of one way ANOVA. However, say one variable more than 2 categories within the subject, if you want to verify, we need to make use of repeated measures ANOVA. Of course, whether it is between subjects or within the subjects, we need ANOVA under the category of parametric tests. Coming to the non-parametric tests, of course, between subjects we can test with Kruskal-Wallis test, whereas within the subjects if you want to test, we have to check Friedman's test or Moore's median test. Coming to the parameters and estimators, parameter is a population constant which is a measure or a numerical value which can have an idea, which can give an idea about the total population. It is something like a measure which applicable to the total population, and it is either the population might be, the parametric may be hypothetical, iconic, numeric and characteristic. So, in the parametric case we considered mostly numeric. So, mostly it has estimated, not to be calculated. Parameters cannot be calculated, they have to be guessed, they have to be estimated. Why? Because we are unable to make use of the total information of the population due to so many unexplained reasons, right. Now, what is estimator? Estimator is something like deals with the sample. It is a functional form of a sample observations. So, we have to explore the functionals. For example, if you want to find mean, that is a function of sample observations, then you call it as estimator, that is called sample mean. Sample mean is the estimator. If you say population mean, that is the parameter. So, functions of estimates and statistics. Statistics and estimate are the singular forms where you can get the, it is also again function of sample observation, but estimate and statistics will speak about only part of the population, part of the sample. So, one time sampling you call it as estimate, more than one time sampling you may call it as estimator. So, of course, estimator is a representative of parameter, it is a replica, it is a guessing value of the parameter. So, it is a one time or partial value of the estimate. So, ANOVA is an analysis tool for testing the significance of difference between more than two means, or you can call it as greater than or equal to 3 means, then you can make use of ANOVA. The systematic factors have statistical influence in the given data set. So, the random factors do not have such influence on the data given. ANOVA is developed based on certain assumptions. What are that? ANOVA can be concluded if there is no relationship between the subjects. This means that subjects in the first group cannot also be in the second group. So, what it means that independent samples are between the groups. Now, there is a different groups levels must be equal sample sizes. ANOVA can only be conducted if the dependent variable is normally distributed. So, one way ANOVA it is making that it has one categorical independent variable, also known as a normally distributed continuous dependent variable. What it means that the study variable is in continuous scale and the comparison is in categorical variable. So, one variable which is in continuous format which can be categorized into more than 3 or equal to 3 groups, then we need one way ANOVA. So, independent variables divides cases into 2 or more exclusive levels or categories or groups, both are all are synonymous. So, the one way test for differences in the means of dependent variable is broken down by the levels of the independent variables. So, what the phenomena it is going to be happened that as an example of one way, ANOVA includes testing a therapeutic intervention. For example, it is an example I am speaking, CBT, medication, placebo are the 3 categories, and on the thing that you are going to study, the depression is a measure, depression, incidence of depression is the measure. If you want to analyze what is the factor of CBT, what is the factor of medication, what is the factor of placebo, that will influence on the incidence of depression in a studies of clinical studies. What do you mean by two-way analysis? For example, the continuous scale variable is 1, but if you want to study in both dimensions, then you need to have two-way analysis. The name itself indicates the meaning. It has 2 or more categories independent variables, also known as factors, and normally distributed continuous interval dependent variable. Dependent variable is in continuous scale, independent variables more than one independent variables with more than 2 categories, if you are saying, that is called two-way ANOVA. It is also called factorial ANOVA. So, independent variables divides cases into 2 or more mutually exclusive levels or categories. So, in part 1, we discussed about the notions of sample, population, estimator and parameter, parametric testing and non-parametric testing when there are more than 3 groups using one-way analysis of variance as well as two-way analysis of variance. Thank you.